So we are talking about 4G. Now I think with this background, kind of get the light off, so it's going to get kind of dark. Okay, so graphs of logarithmic functions. So like I said, we are going to be using technology, and I will go through the steps for both decimals and TI-84s as we continue on here. So don't forget about your stat box. So we're going to start by just talking about some basics. So we're going to look at a chart and two graphs that I pulled directly out of your textbook. So that chart and that graphs you don't have to necessarily write down. They're right out of your textbook from this 4G. But we're just going to talk about some basic things. And then what we're going to do is we're going to take one equation and do a whole bunch of stuff with it. So here are the basics. So remember that our logarithmic function is the inverse of our exponential function. So in this chart, the very first function we have is the exponential one. So those were from chapter 3. And then this other half of the chart has the logarithmic function that's the inverse of that. So remember, they undo each other. So when we think about the exponential functions from last chapter, when we take some kind of base and raise it to a power, the domain is all real numbers. Because I can plug in any value for x. I can plug in negative numbers, I can plug in positive numbers, I can plug in fractions. I could even plug in like an irrational number like square root of 2 if I wanted to. But any number for x will work out. But if you remember from Friday and Monday, we kind of talked about that there's no value of x that will give us a negative answer, right? Remember we talked about that? So because we cannot have a negative answer, the range is going to be y such that y is greater than 0. Remember, y greater than 0 means positives. So for those exponential functions from last chapter, the y was always positive, but the x kind of went on and on left and right. And because the y's cannot be negative, we ended up with a horizontal asymptote going through like the x-axis at y equals 0. Now, we will take a look at this on these graphs in a second, so we're going to kind of recap it. But the connection that I want you guys to see is that because the logarithm is the inverse, the domain and range kind of flip-flop. So for our logarithmic function, my domain is that those x's have to be positive. I cannot take the log of a negative number, and I cannot take the log of 0. Those are going to be undefined. So notice how, like I said, the domains kind of flip-flop, the domain and range. Same thing here. I can only put in positive numbers, but my range is going to be all real numbers. So I'm going to keep going up and keep going down, like up and down, but even though my x's are only positive. And because those x's are only positive, we end up with an asymptote at x equals 0. So like I said, that is in the textbook if you didn't copy that down and you want to. So we're going to look at two graphs. So we're just going to talk about this, okay? So we've got the graph for our logarithm for when our base is in between 0 and 1. So that'd be like a base of 1/2 or 1/4 or 3/4 or something like that. So keep in mind right here, this solid line is our logarithm. So we can see that there's like an asymptote here at x equals 0, just like we talked about. Those x's are all positive, right? X has to be greater than 0. But we're going up, 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 and we're slowly going down, 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 so that y's are all real numbers. Now the dotted line is that exponential function, so we can see that the domain is all real numbers, but I've got an asymptote here, and that my range is positive values. So it just kind of shows you, do you guys see how they're the mirror image of each other, like the dotted line and the solid line? So similarly, if a is greater than 0, we get a picture that looks like this. So all of those same things are true about the domain and the range and our asymptotes. So this just kind of gives you an idea of some of those basic functions of what they look like the general shape. So our exponentials are kind of going up like this, and then our logarithmic ones are looking like that. All right, so we're doing this sort of in a different order. than we have in the past, but what I want you to do is write that down, the function. So the function is 1 minus 2 times the log base 2 of x. So we're going to take this function, we're going to graph it, we're going to talk about the domain and range, we're going to talk about the asymptotes and the intercepts, we're going to do a little solving, and we're going to find the inverse. So we're going to do a whole bunch of stuff with this same function. Now, on your assignment, it lists sketch the function is like the third thing you do, but we're going to sketch the function first. And we're going to use that to help us answer some of those other questions. So you can do that out of order on your assignment too. So it does say use technology, and what kind of got covered up is that you may need to change to base 10 first. However, Decimals.com and your TI-84s and your TI-83s, they do have the ability to use logs that are not in base 10. So we're actually going to skip the change of base stuff. But we know how to do that, right? Because we talked about it yesterday. So we're going to skip that change of base because we've got the technology to skip that step. So we're going to. Everyone has that written down? Okay, so we're going to go to our technology now, and we are going to graph it. And so I'm going to do decimals first, and then I'll go over the TI-84s. So I'm going to start typing it in, 1 minus 2. If you're using a calculator, you can do that step too. So if you're using the calculator, get that far and then wait for me. Now, if you are using decimals, you have to make sure you have your keypad up like this, and you see where it says functions. Hit functions. Usually it starts out on trig, so then you have to go over to where it says miscellaneous. And then it says log A. You're going to hit log A. Then you can type in your little base 2, and then make sure you arrow over to the parentheses and type in x. Now, if you are on, let me just press enter. Yep. So if you are on the graphing calculators, once you get this far, you have to go to the button that says math on the left. Once you hit math, you have to scroll down and scroll down and scroll down until you see where it says log and then base like this. So this is for not the decimals people, this is for the graphing calculator. So hit the 1 minus 2, but then you have to go to math, scroll down until you find the, I already did mine, but you have to scroll down until you find log base A. Once you hit log base A, then you can do what we just did, put in the base 2 and then put in x, and your graph should look very similar to that. So what you should do and what you want to do on your assignment is draw a little sketch of this. And so we can kind of see like we've got this asymptote, right? Just like we talked about, where it looks really close to 0, but it doesn't quite touch it. Also, it looks like if I was sketching this out, especially if I was using not decimals, if I was using like a calculator, I would kind of say, well, it looks like I'm going through at about 1.5, right? Like it looks like I'm going through the x-axis at about 1.5. So that's what I would do for sketching it. It's really cool on decimals is I can click that. And I will show you how to get this on your TI-84, just a couple of examples from now. So we can actually use the TI-84 to find that number as well, but we're going to do that when we get to intercepts. So what I did is I took a screenshot of this, so we're going to look at this picture when we do the domain and range and everything. So everyone's good with the graphing, the sketching? If not, maybe let me check your technology and see what's happening there. So then if we go back to this, so we already did the sketch. So now we're going to do domain and range. So I just have the same picture, the picture you guys should have on your technology as well. the interruption. Your stat pot is accidentally on. So if I go second stat, I have to turn this off. That should clear it up. Your window's a little foggy. So we don't want to do Okay, so sorry for that interruption. What do you guys see about our domain? If you look at our x values, remember our x values go horizontally. What can we say about our domain? It cannot be 0, and it's got to be greater than 0. And I mean, do you guys see a clue in the problem that kind of helps with that? Well, hey, it does tell you it has to be greater than 0. Look at that. All right, what about our range? Absolutely, because technically this is going to keep going up. It's going to get super, super, super close to 0, but keep going higher. And this is going to slowly get lower and lower and lower. So y is all real numbers as well. So the next thing we're going to do is look at asymptotes and intercepts. Questions on domain and range? And keep in mind that domain and range can help us with asymptotes and intercepts. That's the first thing we're going to do is take a look at those. So again, same function, same picture. Find any asymptotes and the x-intercepts. Yeah, good. I was just giving you guys a second to copy it down. But yeah, you're right. We did talk about it, that if we kind of sketch that in, and we sketched it in on our other graph, that we have a vertical asymptote. I'm just going to do VA. And, oh, wait a second, before I write this down, do you guys remember how do you write the equation of a vertical line? It's a little different. It's not y equals mx plus b. It's an x equals. So remember, vertical lines are x equals, so our vertical asymptote is at x equals 0. Remember then, horizontal asymptotes are just y equals. So we're not going to have any of those, but not for the logarithmic ones. Which kind of brings us to that next point. If our range is all real numbers, then there cannot be any asymptote. So my horizontal asymptote, I don't have one. None. So then we have to talk about the intercepts. So my x-intercept, I can see right here. My x-intercept is at 1.41. Now let's say you are using your TI-84 and you want to find where that is exactly. This is how you're going to do it, okay? So if you're using your TI-84, where did I put mine? You're going to go look at your calculator, and you guys don't press anything, but you see where it says trace. Do you see above it where it says calc? We have to hit that. So you're gonna go to calc, so you're gonna have to use the second key. You're gonna use the second key and you hit the trace button. And then you've got a whole bunch of options, and it says value, 0, minimum, maximum, intersect, and then some calculus stuff. So which one of those do you think our x-intercept would fall under? The zeros. Remember we talked about that in chapter 1, that where we cross the x-axis, those are the zeros. So you're going to select 0. On decimals, you just like click it. Way easier.
Y is blank.
Yep, y is blank. What else? It says left bound, right? So just arrow around on your function and go somewhere on the left side of the intercept. Hit enter. Then it's going to say right bound, so just arrow and hit somewhere on the right side. Hit enter. Then, I know that a lot of you guys are using the technology, but remember, you have to use a calculator on any kind of test for the IB, so that's why we're going over this too. So then it says guess, then you arrow to where you think it is, and then it tells you after that. You guys see it? Those of you that are using it, see how it told you? It is a few steps, but you can get there. So then, see if you can, see if you guys can figure out the y-intercept. So then right bound, hit enter. Yes, I'm going to go around where it is. Okay, so what about the y-intercept? What do you guys think? Okay. Do we cross the x-axis or the y-axis? No, so that's none. So if you guys still need help with the TI-84 stuff, I'm going to keep going, but then do some more individual help afterwards. One thing I do want to mention is that for like this x-intercept, we could still do this algebraically, right? I could still find an intercept algebraically. What would I have to do if I wanted to do it algebraically instead of on a graph? Get rid of the logs. You might not need to. Well, not quite that. Plugging in is right. But we have to plug in 0. So like if I wanted to solve it algebraically, I would have 1 minus 2 log base 2 of x equals 0. Because remember, our intercept is what our x value is when y is 0, right? Like that's something that we've done a long time ago and we've done in like algebra 1. It's still true here. You can still find your intercept algebraically. We're going to do something algebraically on the next one, so I'm not going to finish solving that, but you can. So the next question is how we can solve f of x equals -1 algebraically. Because yes, we could look at our graph and find it. And when we're done with these last two examples, I'm going to go to the graph and show it to you. But it does say algebraically. So what we need to do then is figure out, well, where does the -1 go? In for y, right? It does not go in for x because it says f, the function itself equals -1. So here's my function, 1 minus 2 log base 2 of x equals -1. So that's kind of going back to chapter 2 and knowing how to use function notation. Does it go in for the x or does the function equal x or whatever? So now we can solve. So what's the first step? We have to get x by itself. What's the first step? Subtract 1. Very good. So I've got -2 log base 2 of x equals -2. So then we divide by -2. So we're going to have log base 2 of x equals 1. Wait, what do you got, Julia? No, sorry. I thought you were saying something. I don't know. There could be other ways to solve it. I know my favorite way is Ben and Benny. It just really clicks with me. So I switch this then. So this is the base, the number in the exponent for Benny. So 2 to the first power, I'm sorry, not that. Yeah, that. Oh, yes, that. I was getting this confused with the last one. So what does x equal? 2. So that means that I will have a point at 2, -1 on my graph. So especially if you're using like decimals, you can take a look at that and see that point there. We've got one last thing we're going to do with this function. There wasn't one. Because remember there was the asymptote? So it never processed. Does that make sense? I'm just telling you that point, because that's like our y value and that's like our x value. I'm just making the connection to the graph we already did. And so that point is on our curve. So this is the answer, but this is just my connection to the graphing piece that we're doing. So we can even see that on our graphing calculators. All right, so the last thing we're going to do is we're going to find the inverse. So So same function, but we have to find the inverse. So just like the daily challenge problem, what's my first step when finding the inverse every time? Yep, variable interchange, change the x and the y. You know that I like to write it with the y first because that's what makes sense in my brain. And then I can see, okay, there's my x, there's my y. I can do some change in here. Okay. And that's kind of what I brought up during the daily challenge is everybody should know that. They should see inverse and they should think variable interchange right away. Then we got to do a little bit of work to get y by itself. So what do you guys think first? Yep. So x minus 1 equals negative 2 log base 2 of y. Absolutely. So I've got x minus 1 divided by negative 2 equals log base 2 of y. Honestly, that's a great idea. That's not how I did it at all. That's a great idea. That does work. Okay, sorry. Here's what I was thinking is, okay, what's the inverse of a logarithm? Okay, time out. Let's bring it back. Okay, what if I said, what's the inverse of natural log? What would you guys say? E, right? So like this cancels out because we know that we know that ln is the same as log base e, so that cancels out, right? So if I have base 2, what do I have to do on both sides? Use the power of 2. So these are going to cancel out, so I end up with 2 to the power of x minus 1 divided by negative 2 equals y. So because this was the base 2 right here, so if we do to the power of 2, those cancel out and it gets y by itself. Because we're doing it to both sides, so we're keeping everything equal. From right here, so like if this was log base 17, then we would use 17. However, Tony thought of something really, really smart, so I'm going to have to say it. We were talking it out before. Tony noticed that I could use Ben and Benny here as well because there's my base, my number, and my exponent, and you would end up with the same thing, where you would have your base to your exponent equals your number. So if that way is not driving with you, you can just use Ben and Benny. I think that's a great idea.
It's just it went quicker in my head.
Yeah.
When I looked at it.
No, that's a really good idea. But I have to tell you that if you look in the back of the book is going to say this. So the back of the book is going to say that. So what's the difference between our answer that's perfectly correct and the answer that's in the back? Okay, good. So they took this negative out of the denominator, so I don't want you to panic. Like if you do all this work and then you look and it's not the same, I want you to recognize that all they did is they took this negative and brought it up. So that's x minus 1 over positive 2. So that's negative x plus 1 over 2, and then they just rewrote it 1 minus x. So I just didn't want you to panic when you see that in the back of the book. And again, if you didn't like that way, I do think that Tony's method of Ben and Benny is actually brilliant. Okay, really quickly, just connecting back to the graph. Keep in mind how I mentioned that 2, negative 1 was that point. You guys see how we could also find that answer graphically, even though we did the work algebraically. And then I just wanted to show you guys that, you know, we could go ahead and put that in here. What was that? 1 minus x divided by 2. You guys notice how it's that reflection like we saw earlier today? Yep, so if you wanted to double check that you did your inverse correctly, you could always graph it and make sure that they have that mirror image reflection. All right, So in your StepX, whatever part that you find most confusing, star it so you make sure you can go back to it and ask questions if you need to. And then just take a second to think about your preferred use of technology. So if your preferred use of technology is using the calculator and you need some more one-on-one with that calc function or something like that, you might want to let me know so that we can work that out. Especially if you're IB testing, it's the most important, I would say. So on your assignment, 1A and 2A are those types of problems that have lots and lots of steps or parts. So you don't have to do them in order because it says find the domain and range, then find the asymptotes and intercepts, and then graph. So if you want to graph them first, then you can do that in a different order. So that's why I have all those other notes up there.